Hey everyone, welcome to the Patreon video. We're here to learn the basics of physics simulations. So let's just get into it. Let's start with rigid body systems, which, as I explained in the video, is just basic stuff, right? Bouncing balls and falling objects and colliding objects is the basic stuff like that. Let's delete this man. Actually, let's bring in... Did I turn off screencast keys again? God damn you. Stupid son of a bitch. There you go. So whatever I press you'll be able to see that on the left corner. So keep your eye out there if you're a complete beginner. Anyway, let's add an object by pressing Shift A and then bringing in a UV sphere and deleting this man. This is not for complete beginners. You should know at least the most fundamental things about Blender so that this doesn't confuse you. And I would suggest you watch like a complete beginner course on YouTube and then come to this video if you want to get into physics simulations. But yeah, this is how you add a UV sphere. Don't worry about the little things that I do, like I pressed Alt A here, which is just deselect all, or I press Shade Auto Smooth here, which is also another thing. You don't need to worry about these things. You need to just focus on the physics part of it, and I'll let you know things that you should focus on. Anyway, this is the main object. We want this ball to be bouncing, so we set it. We go to this physics properties tab, we go to rigid body and we keep it as active, right? And this is the floor. We want this thing to be the passive thing, right? And it makes sense. The ball is supposed to be active, the floor is supposed to be passive. So you set that as passive, this as active. When you press spacebar, it should fall down. This is how rigid bodies work. Now, if I had another ball here and I pressed play, you'll see they interact. They're almost like bowling balls right now, the way they're falling. See? They're pretty heavy. So the first setting that you should mess with is the mass. Let's make it lighter and let's see if that makes any change. Not much. See, the lighter ball now rolls farther away. If I make this 5 kgs and this 0.1, you'll see that rolls away further. But if I bring this up now and let it fall, you'll see the lighter ball just goes way far and the lighter ball isn't able to push the heavier ball. So the mass is very important on how things interact with each other and the rest of the environment as well. So the first thing you should focus on is the mass, and you set it. Say for example this was a football might be weighing around like 0.25 kgs or 0.35 kgs, whatever is the original weight of it. So we should set it as that. So say we want to make a football, we should set it as that, and that's it. Let's not worry about anything else. If you make it bigger by pressing S, and if I bring it a little further up, you'll see it falls slower because it's now bigger in size. And if I make it smaller and press play, you'll see it bounces a little bit, unlike the bigger size, right? So all this matters as well. Anyway, this is the first thing you should focus on, the mass. What else? The shape is also very important. A convex hull is hard to explain, but if we had this monkey here and we set it as convex hull, what it will do is it will take all the outermost points, like this is the outermost point on the left, and then this is the outermost point here. So it will create a line in between these two things. Rather than taking this whole geometry into consideration, it will just take the nearest outside point, so it doesn't have to compute a lot. That's hard to explain. If you are a beginner, let's not get into all those complexities. Usually you want to set the type to convex hull because it is the most efficient and gives you the best result. But say we have a sphere here, which is a complete fundamental shape. What you can do is, for this scenario, you can set it as sphere because it will definitely get you better results, right? But for something like that monkey head, which is a weird shape, right? There is no, if I set it as an active body, you'll see none of these shapes actually fit. This is not a cone, this is not a cylinder, this is not a capsule, this is not a box. The only two options that you should be worrying about is convex hull, which will match this, and mesh. Convex hull is an optimized form, as I said, right? It takes the nearest outside points, but mesh literally takes everything. Like it takes the whole shape into the whole thing. So if convex hull is not working for you, it might be better to take mesh, to set the shape as mesh, but it will take more computational time. It is less efficient. Okay, so that's how shape works. Now if I keep this here and this here and we make it fall, you'll see the ball it rolls away. But if I had set it as box here, you'll see it would just roll like a box, right? We don't want to do that. So the mass and the shape are the two most important things here. So we'll set it back as convex hull, just to make it simple, right? What else? Surface response. It says friction and bounciness. We can get to that later on. This is not, we don't want to get too deep into each and every physics simulation, but basically you're just increasing the friction and the bounciness of the thing. If I increase the bounciness to 1, nothing happens, because the surface, the passive object, also has like a bounciness factor. So if we change there, you'll see it bounces a little more, right? And if we have come to the passive thing, again, here you also have like a convex hull sphere mesh. You can set this for the passive object as well, and the friction and bounciness, as I explained, you can set it up individually. If you want more bounciness, you come here, but that's like a little more advanced. Let's not get there. Collision margin is again an important field, which basically just means, like, if I zoom in here and I let the ball fall, you'll see that there is a little gap between the floor and the ball, clear gap that you can see here, and we don't want that in a lot of instances. It's good to have a little bit of margin, but if it's a close-up shot, you don't want that gap to be visible. You just come here, set the collision margin to margin to 0 on both these, the passive one and the active object. When we come here, you'll see there's no gap, right? It's touching, the lowest point of the sphere is touching the highest point of the plane, basically. So these three fields are the most important. We're not getting into the collections or the dynamics. Let's not go there. Just things you should focus on is the scale of the thing, the mass of it, the type, the shape of it, and the collision margin. These are the three basic fields. Then we come here, the scene properties, and you'll see there's a column here called rigid body world. Here, the only field you should care about is speed. If you want to make a slow-mo shot, if I set the speed to 0.1, you'll see the ball falls much slower, like a slow-mo shot. Right? It didn't complete because the keyframes got finished. If we make this as 5,000, increase the size of the animation, right? Let it fall. My God, this is way too high. Let's start here. This is just slow motion. If I add like another sphere right below here, we play. You'll see it falls down very slowly, which is a nice little feature. It costs you thousands of dollars to do it in real life. So speed is an important field, and you can also set gravity. So say you don't want it to be on Earth, you can set it to 0.373, and that would be the physics of Mars, right? Gravity slowed down. If I set it back to minus 9.8 again, it falls faster. Another thing that you should take care of, and this is a little more advanced, but this is something that you should know, not that you, just because I told you, you should like use this feature, but there's an animated field here, which basically means if, say, this was animated, like you want this to start here and end here on the, 50th frame or something, you want it to come here, right? If you don't check animated, you'll see it will just ignore those keyframes. When I press animated, it will follow those keyframes, right? But then it will not follow the rigid body physics. So what you have to do is enable animated from the 0th frame to the 50th frame, right? And then on the 51st frame, you have to disable it and keyframe that. And then when you play, it will fall down after the 50th frame. Now this is complicated. You don't need to get into it. So say you were trying to break a wall, right? And you want the ball to have an initial velocity. So you can animate that initial velocity and then turn on the rigid body physics, basically. If this doesn't make sense, you can just ignore whatever I just said. One more thing. If you have a slow computer, all these, even simple animations like these might be really heavy for you. That can happen. If this is all slow, right? This could be very, very slow on your computer, depending on what hardware or what CPU you have. All the rigid body stuff that you see here, all that processing happens on the CPU. This doesn't have like GPU acceleration, not as of yet, at least not in Blender, I think. So if you want to process the data first, like generate a cache and then view the simulation. What you have to do is come back to the scenes tab where we set the speed and the gravity, and then you press bake. We set simulation start at 1, end at 100. We press bake. What it will do is it will create a cache. This yellow line that you see here is the cache. So the computer won't have to compute it real time. It will create a cache file and then you play it and it will be smooth. So for weaker computers, always bake. What I would suggest is, irrespective of what kind of computer you have, you should always bake your simulations. Even the things that I'll show you further on, always bake before you play, because Blender can crash if you just try to play something really heavy real time. Another thing to keep in mind, if you have like multiple objects and you want multiple objects to interact with each other through rigid body simulations, you see there are a lot of objects, not a lot, but if you like duplicate it multiple times, boop, 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 boop. You'll see the more objects you add, the slower the simulation gets, right? So the only thing, like say you had like 5,000 of these objects, you don't want them to have a lot of geometry. Like this sphere alone, if I go to statistics, you'll see has 512 faces. That's a lot for a singular object. What you would want to do is, for a lot of complex objects in the scene, if you want to apply rigid body to a ton of them, it's just easy to get this number as low as possible. You do that through modifiers. There's a decimate modifier which helps you reduce face count. You'll see it gets lower poly as I reduce the ratio, right? And the computer, the CPU, will just find it easier to compute the physics of this shape with only, I don't know how many faces, 39 faces is much easier for it to process. So the face count and the geometry density matters a lot in rigid body as you increase the number of objects in your scene. Yeah, that's it. That's all I wanted to say about rigid body physics. Let's get to soft body physics now. Okay, let's get to soft body simulations now. This is a little different to rigid body physics. This gives the body that is going to be active a little bit of squishiness. And here, what you have to do first is, I'll turn everything off. So say this is the land. This is the place where we want, this is the passive object in this case. This is the surface that we want to stay constant, like it's the ground here, right? So, and this earth is the active object here. What we have to do is set this as collision and not as rigid body passive. This is what a lot of beginners get wrong. They think that they just have to come back to rigid body and set it as passive. But in soft body simulations, you have to set this as collision, which is a different field, right? Rigid bodies is a separate entity and soft body physics are a little different. So you have to set this as collision, and then you come to the earth ball thing. We'll make it bigger. We'll set it as soft body, right? And once you once you press play, you'll see the earth just wiggles around for no reason. What you have to do is come here and disable goal. I don't know what the fuck this field is. I still can't figure it out. You can just ignore this whole column of settings, right? Now if I press play, you'll see the earth, it slows down a little bit because it's a heavy simulation. I think the earth has a lot of geometry as well, which we should fix. As I showed you a little earlier, we can just use decimate and make it as low poly as possible, just so we get a little better. Oh god, Blender crashed. That can happen a lot as well. Actually, it will happen more often than you can tolerate. So yeah, be ready for that as well. Decimate 0.1. Apply. There we go. What the fuck did you apply? Not the soft body, you idiot. There we go. Now this has soft body, right? We turn off the goal setting, right? And then if I bring all of this back to the default settings, you'll see when I press play, the earth just crumbles like a big piece of, I don't know, like a plastic bag almost, which is a great use case for soft body physics. That's because we need to set some things. This will also be 1 kg. So in your case, probably this will just fold into itself and crash again. Because I'm recording the screen and recording audio, that might be the reason for all these crashes. Okay, So it will fold into itself, but we want it to be like jelly. So what we do is we come to the physics properties tab and we close everything else because this is confusing. All we need is this panel which says mass and this edges panel. That's all we need. And the settings we need to change to make it more stiffer. We just need to make this number a little higher. This can only go up till 1, but I would suggest that you don't go above 0.9 for this field through experience. Just believe me, right? Now it still crumbles because we need to set this bending value to something. So this will go as high as only 10. So a value of 10 will allow it to not crumble, basically. You see now it's stiff like a ball, but if I set it to 5, you'll see it folds up like a beanbag a little bit. I think this value is way too high right now. Let's make it 0.5. You see, it has like a ball structure. Now if I make it 1 again, you'll see it crumbles back, right? It wiggles a lot. It almost feels like jelly. So the values to set, like the whole game of Softbody Physics is set by 3 values. First of all, pull and push, and these should be the same. Let's not mess around with different values here. That gets really complicated. The lower this value, the more flimsy the whole thing will get. You see, it crumbles back again. Now, if I set it to 0.5, the stiffer it will get, right? And the lower the bending value, the more crumbleness again you get. So the stiffer you want something, you increase this value and you increase the bending, and the stiffer it will get. Now, if I want the physics of like a football almost, I'll set this to maybe 5. You see, it gets like that bounciness of football. Maybe we can even go to 3 here. Right? That's fun. You couldn't do that in rigid body physics, not well at least. Now, if I increase the mass here, you'll see a lot of stuff changes. You'll see it gets weird again. It gets like, it's like an iron ball that is squishy, right? So increasing the mass changed everything. Setting it back to 0.1 will make it way more bouncy, I think. Right? It made it stiffer, which is weird. Heavier made it flimsier, but lighter weight made it stiffer, which is weird. So what you want to do is you set the mass first. Again, a football might be weighing 0.35, right? And then you see what you get. This is way too stiffer. So what you want to do is reduce the bending value, reduce the pull and push to something like 0.25 and see what you get. This is way too squishier, so we'll make this 3. This is a little better. Maybe we'll make this 0.35. You see, it's getting there, right? So the only 3 values that you need to care about is mass, push and pull, and bending. Now, I will tell you what plasticity does. Now, this value goes up to 100. If I set 100, you'll see whatever shape it got after that collision, like it fell down and this dent got created, right? Right here. What it will do is it will not try to retain its original position. It will just take that position, like take that shape and sustain it for a longer time. Now, if I set this to 50, it will do that same thing, but at half the value. See, it tries to come back a little bit, but it still sustains that value. Now, if I set it to 0, it will not do that. It will come back to its original value. It will ignore that shape, right? If that makes sense. So it's a fun value. So the only values, let me reiterate, is mass, push and pull, plasticity, and bending. Those are the only things you should be messing about with in Softbody Physics. And yeah, of course, you can increase or decrease the simulation speed, just like in rigid body. You can make this slow motion. Now, if I make it 0.5, 0.1 is way too slow. This will be half the speed. Look at those wiggles. Damn. That's fun, right? Okay. Nobody get bad ideas. I know how you intend to use Softbody Physics. I know. No. I know how you think. Okay? Don't do that. Or maybe do that. Who cares? Right? If you do, send it to me. Huh? I think that's it. I think there's this cache panel, which again, as I said, you should bake everything. Bake everything before you play so that Blender doesn't crash. Right? Now we have baked it. There's no pressure on our CPU. Everything is smooth. And I think that's it. Let's get to cloth simulation, which is another fun one. Okay, let's use this person. Now here as well, say I want the cloth to interact with something like that Softbody Earth did with that floor. what you want to do is set it as collision. Don't go to rigid bodies. Rigid bodies are only meant to interact with each other and nothing else. If you want these other simulations to interact with something, say you had a fluid simulation or a fire simulation or soft body or cloth simulation, and you want something to interact with it, you need to set that object as collision. Okay? You need to keep that in mind. Don't go to rigid body and set it as passive. Anyway, I'm realizing, because I'm doing this for the first time, making something for beginners, I don't think I'm explaining anything about Blender. I'm just giving you an introduction into the physics system. I apologize for that. I'm very new to this beginner space. This is the first time I'm making something for beginners, and I'm sure I'm horrible at it, and any newbie is feeling more confused than, I don't know, informed. So let me know what I'm doing wrong, and I'll keep on this path. I'll try to explain everything as well as I can for beginners, but I'm sure I'm horrible at it. So let me know how bad I am or what I could do to fix it. Anyway, let's get to cloth simulations. What you have to do for cloth simulations is, so we want the man to be the collision object. So we have set it as collision. We bring in a plane by pressing Shift A and then plane, and then we bring it up a little bit using G. Okay. Our screencast keys are gone again, which is annoying as hell. We go to screencast keys and we turn it on. We turn it the fuck on forever. Please don't turn off. Anyway, so we give it cloth, right? We click on cloth. We don't set anything, right? We just press play. And you'll see it just falls down in this weird way. It tries to interact with the man in a weird way, which is weird. That's because if you press tab and go into edit mode, you can see it only has 4 vertices and 1 face, right? If I press here, press statistics, you'll see it just has 1 face, 4 vertices, 4 edges, right? Just as a plane should. What you have to do is right click on it, press subdivide, subdivide, subdivide at least 4 times, right? Now it has a little bit of geometry. Now if we play this animation, you'll see it starts acting more like cloth. If we do this few more times and press play, it will act even more like cloth. If we do it one more time, this falls like a cape, but the head, you'll notice it just goes through the head. So how do we stop this thing going through that head? Again, you could keep adding subdivisions, but that will just make everything slower, but it still goes through it. The first setting that you should mess with after the subdivision. So you first need subdivision, right? For cloth simulations, subdivisions are the most important thing. The higher the subdivision, the higher the quality of the cloth simulation. But you come here and the first field is quality steps. If you make it 10, you see it doesn't go through. The head doesn't pop through the cloth because we increase the quality of the simulation. What this basically means is it's just calculating the cloth simulation a little more, right? We can make it even better. This is the first field you should mess with, but you shouldn't start off at 10 or 25. This 25 is the highest value. You should take this to, right? You see how better the cloth simulation gets with 25, but at 5, it was just popping through that, which is not good, right? So this is the most important field after subdivision, but you don't set it to 25 right away because then things will be very slow. You start off at 5 or 8, something like that. Like if we set this to 8, it doesn't pop through the head. So we can mess with things initially and then change it to 25 when we are ready for a final render or whatever value you want to set it to. How do we improve it even better? We can come down here, go to collisions, and here under object collisions, you can increase this value to 8 and it will get slightly better. So by object collisions, they mean this man, this human being is the object. So if you want to improve the interaction between a cloth and an object and the collision in between them, you set these quality steps to a higher number, and then you set this object collision quality to a higher number. Okay, let's bring it back to keep everything efficient, but this is more important than that object collision field. If we set it to 15, it looks good, but there are still way too many, it looks weird. So the first thing we need to do is, if I pop up a timeline right here, right, if you go here, you'll see it looks it looks 3D. It looks like it's generated by 3D software. There are too many squares here. The first thing you can do to get rid of that is right click on it and click Shade Auto Smooth. Don't ask what it is. It got slightly better. There's still jaggedness here and there, which we can improve by subdividing it even more, right? That's one thing that you can do. But what I suggest is you don't go above this level of subdivision. Things will get really slow. You see how slow this gets? But you'll notice those jaggedness have improved a little bit, right? But not completely gone. Let's go back to that previous subdivision level, right? What you need to turn on now is self-collision. If you do that, it gets just slightly better. It stops colliding with itself. So say this was the cloth and there was a face here and then another face here. When it folds down and falls like this face usually collides with this if you don't turn on self-collision. But if you turn it off, this will not collide with that face. It will interact with it and come back to its original state. Self-collision, by the way, will make things much, much slower. Unfortunately, it is a heavy computational process, so only turn it on if you really need it. It definitely makes everything better, but turn it on with a little bit of, keep optimization in mind when you turn on self-collision. Anyway, the fields, all these fields, this is just way too much. You shouldn't worry about any of these. This is just crazy. Self-collision is one of them, object collision is one of them, and the quality steps. These are the things you should care about. All that jaggedness can be removed. Now, this is something a little more advanced, but if you keep subdividing something, we can, by the way, unsubdivide as well. If we right click, we go into face mode. Right here is vertex mode, edge mode, and face mode if you're new to Blender. And we go to unsubdivide, we can go one step further back as well. What you can do is, rather than subdividing it again and again here itself, which will make everything much slower, what you can do is add like a subdivision surface modifier, which basically is like a smoothing operator if you're new to Blender. It just smooths everything out. Now if I play this animation here, you'll see all those jaggedness are just completely gone, right? It's much better looking. Now we have turned off self-collision, so all that collision is looking horrible. But if we turn it back on, you'll see everything looks much better. It's not colliding with anything. The mouth is popping out a little bit, but we can fix that by increasing the count to 20. There we go. It's still popping out a little bit, but we can again increase the object quality, collision quality, and everything will get better. So a lot of people, what they do is they keep this subdivision thing above the cloth simulation. You shouldn't do that at all. That will just ruin everything. If I press play now, you'll notice it gets much slower, and we don't need that much geometry. You have to always keep the subdivision modifier below the cloth modifier. By the way, if modifiers are confusing you, this is just when you apply a physics, like when you press on cloth, this pops up automatically. You don't have to worry about this if you're very new to Blender. I'm just giving you an introduction to this whole world, so you don't have to worry about this. If this confuses you, just go on YouTube, search Blender modifiers, and like watch a tutorial, and everything will make sense. The only thing you need to worry about once you get into cloth simulations is you have to keep the subdivision modifier below the cloth modifier, and that will make things much simpler for your CPU to compute, right? What else? Now, the only thing you should worry about in the physics properties tab, as I said, you should worry about quality steps, you should worry about the collision quality, and you should worry about self-collision. The only other thing you should care about is you come to shape, and this is pin group. What you can do here is if you go to this data properties tab, you press tab to go into edit mode. Say I went to edge selection mode and I selected this whole edge here, and then I added a vertex group and called it edge, right? What a vertex group is, if I deselect everything and I come and select here, sorry, I forgot to assign it. Anyway, if I select this and I press assign, what will happen is every time I come back to this vertex group and press select, it will remember what selection I made and assigned it to. And when I press select, it will select that edge for me. So say I selected this and I pressed assign, and I deselected everything and I press select, it will select that edge. Basically, we're just making Blender remember certain edges and certain vertices or faces, whatever you want it to remember. Anyway, so how do you do it? Again, you click on the plane, you go to edit mode, you come here, press the plus sign, you click on a certain edge, whatever you want to select, and I'll show you what all of this means if you're, again, new to Blender. We'll give it a name, call it edge, right? Again, you can name it anything you want. We press assign, and we deselect, and then we press select just to check if it selected the edge or not, right? And then we press tab to go back to object mode. And then what we do is we come to shape and we select pin group, and that name, whatever name you give to that thing, will appear here. And now if I press play, you'll see the cloth ignores that edge, right? It doesn't take that edge into the cloth simulation. It doesn't consider it as part of the cloth simulation. It's basically like you stitched that part of the cloth. You put a stitching over it, and now the cloth simulation will just ignore that part, right? That's a very important feature. Now I selected this edge to pin. What if I went to edge again and I removed the selection and I selected this and this, both of these, right? And I signed it and I press select, deselect, and then select again. We're seeing that the vertex group includes this whole edge and this whole edge. And we go back here and we check that edge is still selected, and then I press play. You'll see it hangs like a tarp, right? So you can make like a medieval market and then put some wooden objects here, and it will look like a shade in a medieval market. Isn't that nice? So that's how you use stitching, or basically it's called, I think, what's it called? Pin group, right? It's basically pinning that set of edges or vertices, whatever you want to call it. So these are the only things you should worry about in a cloth simulation. The last thing that I want to say before we stop talking about cloth sims is you should install this add-on called BCB, Bystat Cloth Builder. This is a free add-on. You can get it for free. I'll link it in the Patreon description if I remember. But basically it just makes like if you want to ignore all these values, right, and want to make it all simple, what Bystat has done is Daniel Bystat, who's the creator of this add-on, is he's made all the important features right here, right? It's much easier to mess around with things here. One cool feature about this add-on, by the way, if you're a beginner, you shouldn't get into this. If you're a slightly early intermediate user, or like you've gotten into Blender, you know a little bit about cloth simulations, then you should install this add-on. And what you can do is, if I go into edit mode and I select like this vertex right here and I press add pin, right, it gives me an empty object right here. And when I press play, you'll see this just automatically created that vertex group for me on that vertex, right? And now if I select this object and I grab it, I can change its direction, play around with it, give it whatever shape I want. So this add-on is really, really cool for doing customizable cloths and stuff like that. So I definitely recommend it. If you have gotten used to cloth simulation, you should definitely install this plugin. Yeah, that's it. That's all I wanted to say about cloth sim, I think. Yep, let's get to dynamic paint now, which is another interesting one. We'll not go into the paint thing that I explained in the video. What we should be talking about is the ripples, which is the most interesting part. So you add a plane again, and just like cloth simulations, what you want to do is subdivide it multiple times. Otherwise, it will not register anything. Like it needs a little bit of geometry before it can register anything. You select dynamic paint. You set this as the canvas. If you remember, if you watched the video, you need to set something as the canvas. We'll set this plane as the canvas, and we'll set this man as the brush, right? And when I press play and I do something, nothing really happens, because if you want ripples, which is the thing I want to talk about, we change the surface type to waves, and then we press play, right? And then if we dip the man, nothing happens. Again, if I turn on timeline and we need to subdivide it a few more times, and then I press play, I do this, you'll see there are ripples here. It's weird and jaggedy. So again, you just press right click and shade smooth. And now if I dip the man inside again, it's still a little jaggedy. It's slightly better. Again, you add a subdivision after the dynamic paint, and things just automatically get much, much smoother and better, right? This ripple effect is the only thing I want to cover. All those tire tracks and footprints, the things that I talked about in the video, they're a little advanced. We don't want to get into that. Ripples are the coolest and the most, I feel like that is the effect that a beginner will be able to use in their animations, because it's easier to use. So all you have to do again is select the plane, go to dynamic paint, set it as the canvas, select the man or whatever object you want to create ripples with, set it as the brush, And then when you press play and you grab that man and dip him into the water, ripples will be automatically created. Now, the only things you should worry about here is if you select the canvas, which is the plane, which is supposed to be the water, time scale and speed, right? This decides how quickly the ripples form and die out and what the speed of them is. So if I set the speed to 0.5 and I play the animation and I dip the man in water, you'll see the ripples are now very slow as compared to before, right? They're very slow. And if I change the time scale to 0.1 or something, you'll see it's almost like getting slow motion. It's how slow the ripples get created or originate from that point, right? They're both basically the same. They do the same thing. So what I would suggest is you just set like time scale or speed, whatever works for you, and see how you want your waves to be, and that's it. The other thing you should worry about is select the brush, go to waves, and this factor is what amount of depth of the brush should affect the ripple. So if I set it to 2 and press play and dip him, you'll see the waves get much bigger. If we set the time scale back to 1, you'll see the waves get much bigger because the impact, we increased the impact basically. You see how much the waves are much bigger in size now? That's because we set this factor to 1. If we set it to 0.1 now and I play the animation again, you'll see the ripples are much smaller, they're not huge as before, right? So these are the only thing you should worry about when creating ripples. Time scale and speed, one of them, whatever works for you. And on the brush, the depth factor. That's all you need to care about here. And that's it. That's how you create ripples through Dynamic Paint. Again, let's not go into all those other settings. If I go to canvas and set this as paint, then those tire tracks and those footsteps and things like that will come, and those are slightly advanced. Like they're advanced for me as well because I've never really used them properly. So I would say you ignore that. You focus on Dynamic Paint only for creating ripples. Yeah. And yeah, again, if you want the waves to be smoother, like you see how jaggedy those lines are, you just add a subdivision modifier, set it to 1 or something. You see the waves get much smoother, right? Don't keep subdividing the plane. I would say keep it to this density or whatever density works for your computer. This works for my CPU. Keep it as low as possible to a point where you're getting good enough results, and then just add a subdivision modifier to just make it a little smoother and much better to look at and to get rid of all those jaggediness, basically. Yeah, that's it. That's all I wanted to say about Dynamic Paint. I think let's move on to the next thing, which is particle simulations. This is another fun one. Let's make a new scene. Let's add a plane, right? Rotate it a little bit. We go to this setting, which is the particle settings. We press on this plus and something happened. A halo kind of sphere appeared, and I'll drag a timeline here as well just to make it all clear. And if I press play, some particles emit from the plane. Now, you will never ever wanted to emit these weird particles. You will always wanted to emit something like a leaf or a snowball or dust or something like that, right? A particle system is for that. In my case, it was coffee grounds, right? So what you want to do is, say I just make like a cube here, right? The first setting you should mess with is go into the render tab here and change this halo thing to object, and then it will ask you what object you wanted to emit. So you click on this eyedropper and you select this cube, and when you look closer, it's emitting those cubes. It's smaller in size, and we'll talk about that in just a minute, but it's emitting those cubes now. If you wanted it to emit leaves, you should have selected leaves. If you wanted to emit this man, which would be a fun little thing, let's select this man, and now this man will be emitted from the plane, which is fun. Now, if you want to increase the scale, which is the second setting you should worry about, you just increase the scale, and now bigger men get emitted out. If I increase the scale to 1.3, this is just trippy now. Isn't this fun? Really fun. If you increase the scale randomness, it will just give each man a different size, which is also a great feature. Now everything looks randomized. This is the basic setup for a particle system. Now if we come to the first tab, which is the emission tab, and we set the number to 10, it will just emit 10 men. If you set it to 1000, it will emit 1000 men, right? frame start is when it starts emitting these men. And if I set this to 10, it will stop emitting these men at the 10th frame. If I go here, by the 10th frame, people are emitted. On the 11th frame, you'll see nothing gets emitted. Only those men fall down, which is based on what the gravity is, by the way. They're falling down because gravity is enabled, right? So you set this to 200 so that they keep getting emitted till the 200th frame. What it will do is it will divide that 1000 object, right? And it will divide it amongst these 200 frames and then emit them based on that. If that makes sense, right? It will keep getting emitted till the 200th frame, and then it will stop after 200. You'll see they just all fall down. So these are important fields. Again, lifetime is how long will an object stay alive. So say I set this to 1, you'll notice all of these objects that get emitted now die on the first frame. If I set this to 5, they'll die on the 5th frame. If I set this to 10, they'll die on the 10th frame. If I set this to 50, they will die on the 50th frame. You see how they're dying here? If I set this number to 25, they'll die a little higher because 25th frame appears here at this point. So if you want them to die really quickly, you set this to 25. And lifetime randomness is just like scale randomness. It changes the lifetime of, like, this almost looks like rain, if you notice. Like some droplets will disappear quickly, some of them will stay longer, right? So these are really important fields. These are things that you should care about. But then comes velocity, which is also a fun one. Now this emitting towards its normal, right? Which is facing, I think, this direction. This is the normal for that, and that is set to 1. All of the rest of them are set to 0. So that's why it's emitting in this direction, right? If I increase this now, you'll see the objects get emitted in this direction, like a higher speed. They're going in that direction, in the normal direction, by 7.41 meter per second speed. So you set that to 10, it will almost shoot those men into the sky at the velocity that you set here. If you set it to 0, they will just fall down. Previously, when it was set to 1, you'll see they were just going up, slightly up in that normal direction and then falling down, right? If you set this to 0 now and set the tangent to 1, now see the tangential direction is here, which is like, I don't know if you know what a tangent is. Let's not go there. Let's not go into the tangent of what a tangent is. Basically, a tangent is facing towards, it's hard to explain. Anyway, so tangential direction is here. So if you set that to 21, it's sending that object in that direction with that particular speed. If you wanted to go in the y direction of the object, which should be this direction, right? Let's set it to x because we haven't seen this direction. If I set object aligned x, right? If I press this, it's going in the positive direction because this is the positive x side. If I set it to -11, it will go in this direction. So all of these fields are just to set what direction the particles should have when they get emitted. This is what this section is for. So you can just come here, mess with all the fields and see what gets you the result that you want. I'll just set everything to 0 so it just falls down like rain. So that's an important field. Rotation is just here to give these objects. Right now you'll see they're all falling on their feet, like the head is on top and feet is, I don't know how to put it, like they're falling in the same direction. They don't have any rotation attribute. But if I click randomize here, they'll fall randomly. They'll be born with different rotation basically. Some will fall straight down, some will be birthed in this direction, some will be birthed in this direction, and they'll fall down in different directions. So you keep randomize as 1, all of them will have weird random values. If you set it to 0.124, they have a little bit of rotation, right? And what is phase? Now see, we get into weird territories now with phase and randomize phase. Let's not go there. Let's just set randomize as 1, and you can mess about with this and see if you get any result that you like, and you can set it to that. Don't be afraid to just play around with these values anyway. Okay, the final tab that you should worry about is the physics tab, and here too, let's not worry about mass and Brownian motion. Let's just look at damp. Damp basically makes everything much slower, but they fall down slower as well because the depth is set to 25. I've set this to 500, right? they'll be on screen for much longer. Let's reduce the size of these objects. It's getting kind of crazy, right? So if you increase damp, it will just slow down. It's like a field that you can use to slow everything down. Like snow would fall like this, right? If you randomize the rotation here and bring the phase back down here, isn't this how snow falls? If we decrease the damp here, this is how snow falls, right? At this speed. So damp is to slow them down. Even drag, I think, slows them down. I don't know what drag does. Even I don't know what drag does. So we'll ignore drag. This is all you have to care about. Damp is to slow them down. You keep it at 0 and they fall much faster. What if I set it to -10? Nothing happens. You can't go below 0. So that's good. What else? Now all these other fields, you can mess about with them, but mostly the only fields I usually need is this velocity tab, this emission tab, and then you come to physics, and damp is, I use it to slow things down or make them normal speed. And scale and object is like, that is the most basic thing. Other than that, there are other things, like you can reduce the gravity to make everything slower, right? Instead of the damp field, but I usually go for the damp field. Let's not mess with the gravity for fun. Right, that's it. Yeah, that's the basics for particle simulations. That's how I made every shot. These are the only fields I used to make every particle shot that you saw in the commercial. So yeah, that's it. Now let's end it all with force field simulations, because this is a beginner friendly tutorial. We will not go way too deep into fluid dynamics and smoke and fire simulations, because those are just inherently very, very difficult. Both fire, liquid and smoke simulations are a little harder to grasp. Okay, let's now go to force field simulations. How you add force field simulations, you go to Shift A, add a force field. Let's add force, right? It adds this little thing. Now, when you press play, nothing happens because force fields are kind of weird. Now, if I bring in this timeline, just to make everything a little more clearer, for the force fields to actually start doing something, you need to set this as an active rigid body, which is the part that most people get wrong. Now if I press play, the rigid body falls and still nothing happens because the force has no strength. If we select the force and then we give this a strength of, 10, right? And then we keep this object somewhere further away, still nothing happens. I think the strength is way too low. Now it goes away from the point. Now if we set it as -1000, it will pull it in like this. Almost like a magnetic force pulling that man in. Isn't that fun? If we increase the noise, you'll see it will take that -1000 and pull it with different values. Like maybe sometimes it will pull it with 800, sometimes it will pull it with 300, whatever it is. So those are the only two fields you should mess about with: strength and noise. You should make noise 0 if you want a consistent field of energy. If you want a little bit of noise and a little bit of randomness, you set it to 10. It doesn't go above 10, so you can keep any value between 0 and 10. And then the strength, the higher you go, the higher or the faster it moves. Now if I keep this object further away, you see it will keep losing motion eventually as well. If I increase the noise here, you see how it's getting a little noisier, the direction is changing a little bit. It's going here, here, and then changing the direction slightly. I don't know what flow does. I don't know what wind factor does. I've never used those settings. This is how you set force fields, but this is not interesting at all. If I set this to -500 now, right? And we bring that man closer to the field, this is not fun for anybody, right? But if I add another man here, they start interacting, which is a weird little... Okay, we need to place them in a nice way so they actually kiss. Ooh, just missed. Come on. Because they're both rigid bodies, they're bound to interact. I don't think they're interacting. Let's bring in a sphere. Mesh, UV sphere. Give it a rigid body. Give another one a rigid body. You see? They stick together like a couple of balls inside your pants. What? If I duplicate it again, all the 4 balls interact with each other. If I increase the strength to minus 5000, you'll see they crash with a harder force. And then they just stick around and do weird things. If force is just one of these force fields, what if we add like a plane, right? A quick cloth simulation recap. We'll subdivide it multiple times. We will give it a cloth. We will come to vertex group. We will select this edge, assign it to a pin group. Come here, we go to shape. We set it as that, right? And now if I play, it will fall down. But if I go to force fields, bring in a wind force, make it point in this direction, make it bigger in size, although the size of the factor doesn't matter, like the size of the force field doesn't matter. If I give it a strength of 100, you see it blows as if there's a wind blowing. If I delete it, it just hangs like a curtain, right? Just hangs like a curtain. But if you bring in the wind, we increase it to 5000 even, it blows in the wind. So you can get like a flag effect if you want. Now wind is just one form of force field. If you bring in turbulence, which is a noisy kind of wind, basically, as you face turbulence in a flight, right? If I set it to 100, I don't think 100 is enough. We need to set it to 5000 maybe. You see how it gets all folded and weird? Look at that. Camera battery just died, so we'll continue this without a face cam. I hope that's okay. Yeah. You see how it's just folding into itself? Now if we move this, you see it changes. It gets weird. Okay, you can come back to the beginning and I grab it and I bring it here. I think we should increase it to 5000 so it gets really crazy. Right? Now if I bring it here, the turbulence force will be here. If I bring it here, it will be here. If I bring it here, it will be here. It's all fun, right? This is how you use force fields. There are only 2 fields you should care about: the strength of it, the noise amount. Now, if you want, all these other fields, magnetic, harmonic, Boyd, charge, they are useful in their own use case, but on like in a daily Blender scene, I don't think a beginner or an early intermediate would need anything other than wind, turbulence, or just that generic force here. These are the only 3 things you should care about. Vortex is for creating tornadoes. Magnetic is for creating magnetic charge effects. Now, we don't need to get into that. That is just way too advanced for anybody. It's advanced for me. I even don't know how half of these work. So you should only focus on turbulence, wind, and this force field here. Okay? That's it. And you should mess with the strength and the noise amount. You can mess with these other things. You can even hover over them and read what they do. Convert effect force into airflow velocity. Now, I don't know what that means, right? So I don't use it. I get whatever I want with the strength field and the noise amount. And if I want some movement, I just move the object. I keyframe their locations and I animate the object, the effector itself. And that's how I get different kinds of motion in a cloth or a rigid body, etc. Now, by themselves, force fields do nothing. They need like a cloth simulation or a soft body. So force fields always need something to interact with. They can't do anything alone by themselves. That's all about force fields. You don't need to worry about anything else. In force fields, I think the only thing left is fire, smoke, and water simulations, which is way too advanced. It's advanced for advanced Blender users as well. But if you want to just get a taste of it, you bring in a cube, you go to object, you go to quick effects, you go to quick, and say you want liquid, right? You select quick liquid, you come here, right? And then you press play and you just have water. The only field you should worry about here is resolution. You make this 64 and the water gets a little more defined. I can't see it in wireframe, but this is how it will look in solid view. Great, isn't it? Now there are way too many fields here, and I would, it's either you hover over them and read what they do, right? But these definitions usually don't make much sense. So don't get into fluid simulations if you're very, very new to Blender. It's just way too complicated. And the same goes for smoke and fire as well. Now if I go to object, quick effects, quick smoke. If I press play, the cube will just generate smoke. Now there are way too many feeds here as well. The only thing that actually matters is the resolution at the end of the day. Now you can control how the smoke will rise, with what speed it will rise, what kind of texture it will have. But all these things, I don't think if you're a beginner, you should get into it. Maybe you can watch like a beginner tutorial first and then get into it. But what I would suggest is you mess with the other simulations first and then get to fire, smoke, and liquid. If you want to make fire real quick, you just need to change. You need to click on this, click smoke to fire. But when you play the animation, it will just look like smoke because, again, as I said, if you're a beginner, this will just confuse you. In order to get fire, you need to actually add like a shader to the domain, and then you need to increase the black body intensity. That's how you get fire. Now, this is all very, very confusing for a beginner. So as I said, you shouldn't get into it unless you are used to Blender. This is how you get fire. Now, this is very low resolution. If I make it 64 and I go back to the first frame, fire gets a little better. If you increase the density, the smoke gets thicker. But again, don't get into fire and smoke just yet. And I think I forgot about cell fracture, which is again a little advanced, but I would still like to show you. Let's do it on this. You need to go to edit, preferences, get extensions, go to cell fracture and get this add-on, install this. You will see install here instead of this arrow. Install that, then press F3, which will allow you to search anything you want in Blender. That's how you do it. So, for example, say I wanted to search subdivision modifier that we talked about a few moments ago. Press this and it will just give a subdivision modifier to the whole thing. You don't need to come here, press add modifier and go to subdivision, etc., etc. So if you press F3 and you search for cell fracture, a thing will appear, and this is how you do cell fracture. Now the only thing again you need to worry about here is source limit. This is the number of pieces you want the object to break into. I just wanted to break into 10 pieces, right? Noise is how much noise those pieces have. So you can set it to 1, you can set it to 0.5, whatever you want. It only goes between 0 to 1, right? And recursion is basically how detailed the cracks will be, right? Now if I press OK, let's not worry about anything. This is a little advanced, so this is just to show you how cell fracture works. So it just went through, it created another mesh, and it has those 10 pieces that I set up. You see? This piece is different now, this piece is different now, and this is different, and this is different. They're all separated now. And now we need to apply a rigid body to each of them. If you go to Object, and we go to Rigid Body, Add Active, it will add it to this yellow object only and not the rest of them. Oh, actually it added to all of them. So if you select all of them, that was not how Blender did it previously. So you just press Add Active and it just adds it to all of them. And then if we add a plane here and we set it as a passive object, and I press play, the things break, which is just super fun. But let's not go crazy here, okay? Cell fracture is just way too complicated not way too complicated. It's easier than, I think, what do you call them? Liquid and fire simulations, but it's still complicated enough to discourage a new user. If I set it to 100, the algorithm will go through everything and break it into 100 pieces. You see, there are much higher number of pieces now. If I pull it apart, you see there are much higher pieces. If I select everything, select this plane, select one of them, object, rigid body, add active, press play, all of this falls apart, which is just a cool effect. It's just cool to look at. Anyway, that's it. That's the introduction. Now, this was a horrible beginner tutorial. I'm totally aware of that. I am horrible at this. I'm just getting used to. So usually I'm usually making videos for intermediate users. So I'm not used to this whole beginner teaching scene. I'm trying my best. This was horrible. I understand. So if you have any questions, you can just drop a comment below or ping me on Instagram. If you want like a tutorial to watch, like if something confused you and you can't even find a solution on YouTube, just ping me on Patreon or ping me on Instagram or wherever you want, and I'll just reply back with a link, or I'll help you out. That's the only thing I can do to compensate for the horribleness of this whole video. Okay, now if you want to learn how that whole commercial was made, now that is behind a paywall. I'm sorry, but that's how the world works. I can't sustain being an artist by making everything free. So if you want a breakdown of everything, you go there. It's $5 a month, I think, and if you pay $10, you get access to the source files as well. But $5, you'll get a link to a video like this, and you'll see the breakdown of how everything was made. Not from scratch, the shots are already made, so I'll just explain what the thought was behind making that shot and what are the challenges I faced in making those shots. But this is how Patreon videos usually go. Now, this was not great because this was for beginners, but for intermediate users who know how Blender works, Patreon videos are exactly like this. I just go through everything. I just tell them how I made a shot and what settings I changed and what kind of lighting I followed and how I color graded or sound designed something. That's how these Patreon videos go. So if you enjoyed this, chances are you will enjoy that as well. If you didn't enjoy this, I would suggest you don't get the Patreon or the YouTube membership. But yeah, that's it. That's it for this video. Thanks for watching. I'll keep posting more and more free Patreon videos as well. I'll keep posting more and more free videos for Patreon as well from time to time. So stay subscribed to the Patreon as well, not just the YouTube. Because YouTube is shifting more towards like a mainstream media thing, right? I have to make mainstream stuff there. So if you want specific tutorials, that's what the Patreon is for from this point on. So yeah, I will post free videos from time to time, as I said again. So yeah, stay subscribed here as well. But that's it. That's it for this video. Thanks for watching. Bye-bye.